Hey math kids, today we're going to talk about finding side lengths and using trigonometry. And we are in chapter 7, section B, and there's only one example, but it has two parts. So we're on example 2, and it says find correct to 3 significant figures the unknown length in the following triangle. So this is a right angle. No, it doesn't look like it, but that's okay. So we need to find x, and we're given a 7 centimeter side. So we're going to go back to those ratios, SOHCAHTOA. Watch the previous video if you don't know what I'm talking about with those. So this is our theta, and we're interested in the hypotenuse and the adjacent side. So the one that uses both of those is cosine. So we're going to use cosine. So we're going to say cosine of 32 equals adjacent, which is x, over hypotenuse, which is 7. So once we have that set up, we just solve for x, multiply both sides by 7, we get 7 cosine 32 equals x. And I'm going to pull up my calculator just to show you how to type it in. So the first thing you want to check, you want to go to mode and make sure that we're in degrees. So change this to degrees if it's not. And then we can just type it in. So it's 7 cosine 32. Hit enter. We get 5.94 because it said 3 significant figures. So 5.94. Our length was in centimeters, so this will also be centimeters. Okay, and let's do part B over here, I guess. So we have another triangle, another missing side length, a little bit of information. This time we're in meters. Okay, once again, we start with SOHCAHTOA. This is our theta. So relative to our theta, we have the opposite and the adjacent. So opposite and adjacent in the same piece is tangent. So we say tangent theta equals opposite, which is 5, over adjacent, which is x. Now, there's a couple ways we could approach this. I guess I'll just do it this way. So I'll just multiply both sides by x because we want to clear the fraction. So now we have x tangent theta, which is 64. I should have just plugged in the 64. Oh well. And now we have x times something, so we want to get rid of the tangent. These cancel. So we have x equals 5 over tangent 64. Plug that into our calculator. So we have 5 divided by tangent 64. And we end up with 2.44. So x equals 2.44. Since we had meters up here, we'll have meters down here. And that's it. That's the only example we have. If you need additional help, please come to Math Lab.